This is section 1.7, midpoint and distance in the coordinate plane. Hopefully this is a review for all of you, so it'll be pretty quick and easy. First, we had a midpoint on a number line. That's pretty simple and straightforward. It is just a simple average. Here, if I wanted to find point M, which is the midpoint of point A at coordinate 4 and point B at coordinate 6, we just take the average of -4 and 6. If we take the average, we end up with 1. So that's where point M is. That's the midpoint on our number line. However, in this section, we are going to be doing midpoints on a coordinate plane. You do remember working with coordinate planes, right? So you should be familiar with a coordinate plane which starts out looking like graph paper. This coordinate plane is referred to by a lot of different names. You've got coordinate system. Sometimes it's called the Cartesian plane, named after a famous French mathematician and philosopher, René Descartes, who came up with this system in the 17th century. And then probably the most formal and long name, the Cartesian coordinate system. But most people refer to it simply as a coordinate plane. In truth, there are many different coordinate planes in mathematics. But if you just say coordinate plane, the default one people assume is the Cartesian coordinate system. Let's start filling in the pieces to our Cartesian coordinate system. First, we have the x-axis. Hello, x-axis. And now the y-axis joins the party, late as usual. With the axes drawn in, we can now number our lines. The point where the two axes cross is the origin. The axes split the coordinate plane into 4 quadrants. They are numbered like this. Normally they are numbered using Roman numerals. Quadrant 1 makes sense because that's just where the positive x and positive y values are. But then they decided to go counterclockwise instead of clockwise to number the rest. It becomes apparent in precalculus why that is a standard progression. Finally, every point on the Cartesian plane can be described with an ordered pair. The ordered part refers to the fact that the x value always comes before the y value. So for this point here, the x value is 3 and the y value is -1. So you could write the ordered pair like this. Now that the coordinate plane refresher is over, let's get to the midpoint. First, we started by showing the basic midpoint formula for a number line, but in a coordinate plane it's a little more involved, but not too bad. Here I have a coordinate plane with a line segment drawn in. First, I need to move my coordinate plane over a bit so that I have a little more room to work with. On this line segment we have 2 endpoints. We need to know the coordinates of those endpoints, so you should be able to do this on your own, but the first one is -7 on the x-axis and 1 on the y-axis, so we have, for the other one I've got 5 on the x-axis and -7 on the y-axis, so I have. In order to find the midpoint of this line segment, we need to find the exact middle of the 2 x values and the exact middle of the y values. So we simply take the average of them. This is what the formula looks like. On a number line, we found 1 average. For a coordinate plane, we find 2 averages. The formula is simply an ordered pair, where the first value is the average of the x values, and the second value is the average of the y values. The little subscripts are there, as we have 2 different x and 2 different y values. So to use the formula, plug in our first coordinate, in for x sub 1 and y sub 1. It doesn't matter which coordinate you choose to use first. I will use the point -7, 1. Then plug in the second point, then add, then divide, and there's our final answer. The midpoint is at -1, -3. That's how the midpoint formula works. Pretty simple. Now instead of finding the midpoint, I want to find the length of my line segment. So we need another formula which you should be aware of. This formula is actually based on the Pythagorean theorem, which many of you probably have seen expressed as, we can take our line segment here and turn it into a right triangle like this. Our line segment length is now labeled with a c. That's the distance I want to find. So in my Pythagorean theorem formula over here, let's solve for c by taking the square root of both sides. I end up with this. Notice how similar that looks to our distance formula. In our distance formula, we have x sub 2 minus x sub 1. That is simply calculating a. We also have y sub 2 minus y sub 1. That's simply a calculation to figure out b. So anytime you are using the distance formula, you're actually just doing a modified Pythagorean theorem. Now let's actually use this distance formula. I've chosen some new points here so that they get a turn too. I don't want anyone to feel left out. To use the distance formula is simply a matter of plugging in our coordinate points. Just like the midpoint formula, it doesn't matter which point you plug in first. I'll use -5, 4 first because, well, just because. Now we plug in our other number. This is tough, but now we have to add. Squaring time. And we end up with the square root of 100, which is 10. So the length of our line segment is of length 10 units. That's all there is to the distance formula.